It was good. Let's. Yeah. All right, so this is going to be your video for section 2.4. And I realized when I was looking at it, so for some reason I was thinking in 2.4. I think I was thinking of a textbook that I've taught out of. I was thinking in 2.4 that they actually started talking about um, measures of central tendency, so averages and standard deviations and all that kind of stuff. I think they just don't do that till chapter 3. So I realized 2.4 is actually a crazy short section, number 1, which is awesome. It's another graph, so it's another way to represent information. And it's one that I'll introduce now. We're not going to use much after this until right at the end of class, basically right at the end of the semester. But I also realized it's a really short, like I said, it's a really short section, I honestly wish I had seen this on the last video because I would have just included it on the last video. Really easy. But either way, let's look at it. It's really, you'll kind of see it's really very little to do. But let's take a look at it. Let me turn this on. This is 2.4 about scatter plots. Actually, before I even show you anything, before I grab a problem from the book that we're going to work on or anything like that, uh, um, you've likely seen scatter plots before. So even if you haven't, just thinking about the word, so scatter, literally, it's a compound word, scatter plots. So what would this mean? So even if you've never seen a scatter plot before, what do you think it means? So plot is just another, we use the word plot when we talk about basically putting points on a graph, right? So plot, it means putting points on a graph. Scatter means all over the place, right? Like things that are not in some order, but all over the place. So scatter plots are literally about, so we're gonna make a graph, we're gonna make a plot, we're gonna plot points on a graph of the data that we have, and it's gonna end up looking scattered. It's gonna end up looking all over the place instead of having maybe some nice line or shape that it fits, right? Um, that's all a scatter plot is, actually. So we're gonna get some data. And you'll see this time, instead of doing a frequency chart, then we're just gonna actually just graph the data. And every piece of data is gonna be a point. There's gonna be a bunch of points on this graph, and you're gonna end up, it's gonna look like a bunch of points that are scattered, i.e. a scatter plot. That's actually it. So this homework is just focused on that. So we'll do probably honestly just one of these problems. And then I'll talk a little bit about, what do you call it? Again, once I organize, so once I visualize data, I always want to move to analysis, right? I want to analyze the data. So we'll talk about a little bit of vocabulary that goes with scatter plots as we kind of look at the trends or the shape or the maybe, again, the data is going to be scattered, but you'll see likely some sort of pattern to it. So we want some vocabulary to just start describing that pattern, kind of like we had the shapes of distributions or our histograms. So we want some vocabulary to describe that so that we can start to analyze that data. So, um, guess let me actually move. So center. Um, let's get some data. Right up 2.4. You're gonna look at that thing here is we really just don't need. play with maybe number 7. Um, So on 7, and again, realize I'm pulling these, I think I said it at one point, but I think I didn't make, like say it, like just make a point of talking about it for a second. I realize again that I'm pulling these problems, by the way, from the exercises at the end of every section. So as you see me scrolling through this, that's all it is that same ebook, that you guys have. Second. Excuse me. So that same ebook that you guys have in Alex, I'm popping up the same ebook that you have. And so right now we're in section 2.4. We found the exercises kind of towards the back half of the section, and we're looking at number 7. So I'm saying that to say, you could pull that up alongside, the video as you're watching this too, if it helps you. Um, but let me actually make this larger though, just let's say number 7. So a study was conducted to determine if the amount a person spends per month on recreation is related to the person's income. So somebody kind of had the idea of, if you have more money, probably spend more, their hypothesis probably was, if you have more money, you probably spend more money on recreation, right? So just doing something relaxing, right? Not something needed for your life, not surviving, not, doing your job and getting to the next day, but recreation, doing something nice for yourself, something relaxing, something easy, a park, etc. And looking at the amount of money people spend on that. So their hypothesis likely was that, call it if a person has more income, they spend more money on recreation. But here's the data that they gathered. And so notice kind of what's happening here is, so this first row tells me, so I think the thing I want to say about this is each of these is they probably handed out a survey or did something or maybe took some averages of some data they had. And for a person who made 800 a month, they found that on average they spent about $60 on recreation. Person who made 1,200 spent about 200. So this is actually not averages. This is actually just a survey, right? So um, this is a person who made $800 a month, spent 60. A person who made 1,200 spent 200. Person who made 1,000 spent 160. 900 spent 135. 850 spent 45, etc. So they literally just handed somebody a survey on how much do you make per month, how much do you spend on recreation, right? So each of these actually represents a person, I guess. They want you to draw a scatter plot and comment on the nature of the relationship. So I want you to notice something that's maybe different. So we first want to talk about what's maybe different about this data compared to the data we were getting for the previous sections. And we want to talk about this because, again, you get something like this on a test, you need to be able to recognize, oh, wait, hey, this is the data they're giving me is different than what I'm normally seeing, and therefore doing a scatter plot. Anyways, but what's different about this data compared to maybe the data we've been getting for the other problems? So maybe you're seeing that the interesting thing about this is, so this isn't a block of data, right? Like we've been seeing, this isn't like, just a bunch of incomes or a bunch of amounts spent on recreation. This is actually sort of a connection or a correlation between two different types of data. So one of the huge differences here is that you're getting two different types of data for every person. So all of our problems or all the data we've been looking at in the previous sections, whatever the survey question was, it was one thing the person was asking, right, or answering. So how many hours they spent on this, or how old was this person, etc. So age, hours, maybe it was money spent on something, but we were asking them one type of information and they gave us back that information, right? But here we're really getting two different types of information for every survey, for every person. We're getting their income, we're getting their amount spent on recreation. So that's the first huge difference here, is there's really two different types of information you're getting per person. So you can almost think about it if you've had a college algebra class or, just been in an algebra class, you can think about it on the previous problems that we did for all the sections before this, you were only getting one variable, one type of, you were getting X values, just a bunch of X values. But here you're getting X and Y values. You're getting two different types of information. So one of the things I want to mention about that then, so if I'm getting two different types of information, so one of the things that happens here is I can't make a histogram out of this. So I want to kind of talk about why we end up doing a scatter plot here. By having two different types of information per survey, per person, I can't make a histogram out of that because a histogram, what happened was we would get one type of information and we would make categories of that information or, categories and then count how many people fit in each category, right? So we'd make categories of that information and then count how many. So on a histogram, so if we're thinking about a bar chart, a histogram, bottom is categories of our data. Sorry, the bottom number line, the bottom axis. But the vertical one is a count. It's just a count of how many fit in each category, right? But if you think about it, we can't really do that with this because, so like if we just had income, then we could make ranges of income and count how many people fit in those ranges of income. Or if we just had the amount spent on recreation, we could make ranges of amount spent on recreation and can, count how many people fit in there. But by having two different sets of data that are still connected with each other, right? There's some sort of thinking where there's some sort of connection or cause and effect here. But by having two different sets of data, I can't make those categories because categories for income are not going to mesh with categories for money spent on money spent on recreation. They're two different things. So we can't then go and count how many, how many fit each category. So thinking about it in terms of this, this picture, this basic kind of graph that we get for a histogram, the problem here is basically both of these would have to be categories. You'd have to have a category here of, say, doesn't matter, but let's say the money spent on recreation. We'd have categories here for the money spent on for the income, but then you couldn't graph it. You couldn't write a rectangle because you would need to count this axis would need to be a count in order to draw a rectangle. So that's kind of the problem that we run into when you have data like this, where it's two different types or two different things that they're measuring or two different types of data that you're getting from every survey or every person. Problem is, this would be categories, but this also would be categories. And then we couldn't graph bars on that because you would then need bars going this way and bars going this way, and you would end up with a weird checkerboard. So it just doesn't, once you see that you have two different types of data that we're tracking, it just doesn't make any sense. This doesn't do anything for us. So we can't do a histogram with this. But like I was mentioning, and they kind of suggest it by getting the XY there. If you see two types of information, it's kind of like one is an X and one is a Y. And if one is an X and one is a Y, then again, already in classes that you've taken before in math, how could you graph that? How do you graph X's and Y's? Good. You just turn this into your X's, turn this into your Y's, and you graph dots. So the way that you've been graphing in algebra classes ends up being perfect for a situation like this when your data is like this. So now my graph instead of being, again, it's almost like, instead of just being, or what do you call it? It's almost like you have your categories. We could say this could be categories of income. This could be categories of, keep forgetting the words here. We'll just call that recreation. This recreation. And then what we would do is we would figure out our lowest and our highest for each of these categories. And we would figure out how to or how we want to count on each axis. And then we would just go graph. So this idea that you need both sets of categories actually then, again, so I think I'm wording this horribly, which is why I keep talking so much. But fact that we have income will end up being here and recreation here. Honestly, even instead of just doing categories, I just want to graph this like I would in an algebra class. I want to make a number line on the y-axis that'll cover my recreation. I want to make a number line on my x-axis that'll cover my income, and then I want to go graph these points. So again, the huge difference here is you're not counting, you're not getting a frequency, you're not breaking things into categories. You're just graphing points. You're treating each of these like a point, like an X and a Y. You're just going to go graph it. And that is a scatter plot. That's the big difference. We're not going to do a histogram. We are just going to, and you could think about it like you're creating categories now, both for recreation and income, or you could just think about it like your vertical axis is going to be your number line for recreation. Your horizontal axis is going to be your number line for income, and we're just going to graph the points. Let me draw this, start drawing this out over here. So visually, once you have that idea in your mind that you're just graphing X and Y, what we still have to do, like we did for the histogram, is you're going to have to decide, your vertical axis has got to cover, in this case, the amount spent on recreation. So you've got to start at 0, you got to figure out the highest number here, and then how you want to count. So how you want to break, just how you want to count along that y-axis. And then you're going to do the same for income. Although with income, we could probably don't have to start at 0. Should we? Yeah, but anyways, but actually, honestly, so just very much like we did for the histogram, you're going to look at kind of the low and the high on your income and split up your number line to kind of cover the lowest and the highest, and then figure out how you're going to count between those. So what you're doing with the horizontal axis and the vertical axis is actually the same thing you did for a histogram. It's just now you're going to get dots on the graph instead of rectangles, instead of bars. So I want to give you guys a second to do, we don't even have to get the whole graph going, but I at least want you to take a second and see if you can decide that the first two parts. So on the vertical axis, again, our vertical axis is going to be recreation, amount spent on recreation. The horizontal axis is going to be our income. So I want you to decide how you're going to count on the number line for recreation, and then I want you to decide how you're going to label and count for income, and see if you can do that. Because, like I said, I guess what I want to try to get you guys to latch onto or use is it's the same way you did it for the histogram. But pause on your side, I'll pause on my side. See if you can figure out the X and the Y axis there. See what y'all were thinking here. So for recreation, the lowest I see here is $60. The highest is about 160. I think for something like this, I probably would go down to 0. So we want to go basically from 0. I'm sorry, not 160, 0 to 200. So then you have to kind of decide how are you going to count that out? So from 0 to 200, if we count by 20s, that'll be 10 lines, which is kind of the upper bound or the most that we want to do. If you notice, not everything, but almost everything we have here is either a multiple of 20 or or halfway between a 20. Right, so we'll have a couple that are quarter or 3/4, but other than that, everything is about a 20. So I think that's a good way to break this up. So we need 10 lines total. I probably need a taller. Need them to put more space between these paragraphs is what I need. I guess let's do it this way. So 20, 40, 60, 80, 100, 20, 40, 60, 80, 200. Forty, 60, 180. 100. This is going to be recreation. And this is all in dollars. And if you want, like we did on the last video, if you want, you can make little half marks to help the reader's eye see the tens pretty easily. I think in this case, because I don't have a ton of space here, it'll actually make it pretty crowded. I don't know. So let me decide on that. I may end up writing those in. We'll see. But then on the horizontal axis. So now we want to plot out. So the horizontal axis needs to be a number line that covers these incomes, right? Now, again, one thing, I think it would be natural, especially the way that we graph things usually in algebra, is you always start at 0, 0, right? So it'd be natural to start this at 0, and then we'd have to go all the way out to, in this case, the highest we have is $1,200. So maybe we count by hundreds or something like that. But notice that if we do that, I will say that, so if we start at 0, what is the lowest income that they show there? By the way, this is probably, well, maybe it is monthly income. I would think this is actually weekly income, but I'd be wrong here. Anyway, sorry. What is the lowest income you see here? 800. So think visually about if you start at 0 and you're chopping this out by 100, 800 is going to be way over here. So you're not even going to be able to graph any of your dots till way over here in the graph. Now, the first thing is visually, the first thing is technically, is that a problem? No. I mean, it's accurate. So you would have 0, 100, 200, 300, 400, and somewhere over here you would start your 800 to 1200 run and you could graph out your dots. So technically no issue, but visually. So again, think about you're trying to present this to a reader so that they can not only easily see the information, but make a conclusion, a pretty easy conclusion out of the data. To have all this white space, to have to scan all the way over to here just to see kind of the data and to try to get a pattern out of that. So is that effective? Is that good aesthetically, but not just aesthetically, is it effective for making it clear and making it readable and making it something they can analyze? What do you guys think? So probably not. And I do mention that there is an aesthetic thing here. Technically, it's completely fine to have all your dots over here. Completely fine to have all this white space. But think about just the way, just if you think about the way we view the world, the things that we see, the things that we tend to interact with, when you have a bunch of white space, it actually does sort of detract. So psychologically and therefore aesthetically, it detracts from us being able to clearly see something and analyze it, right? Not only just I'm trying to make it so technical, clearly, saying clearly see it and analyze it. Just think about beauty. Just think about like pictures that you see, the widgets on our apps, right? pictures that are all around us, they're usually the things that look appealing and that we pay attention to are things that kind of fill the border of whatever the viewing port that we're looking through, right? Whether it's a frame on a piece of art or whether it's, you know, yeah, it's the frame of your phone, right? So for some video that you're watching, we tend to the things that we pay attention to and see better, look better to us, and analyze better are things that kind of fill the space. Now, the thing that sucks is that it's kind of arbitrary, right? So that's why I call it aesthetics. It's a beauty thing. Our brain prefers to see framing of something not completely full, but really filled out, right? So it is arbitrary, but it doesn't mean it's not important. So if you're presenting a visual for readers so they can see the data effectively and want to look at it and analyze it, then you don't want a bunch of white space because person's gonna maybe get lost with it or just be like, okay, bunch of white space, this means nothing, on to the next, right? Swipe right, on to the next. Um, so you don't want a bunch of white space here, basically. So the end of this is, even though mathematically, technically, it doesn't matter, um, for readers, we don't want a bunch of white space. And so normally we would start at 0 here as far as our income, but we're not going to do that this time. We don't want to do that because we don't want a bunch of white space. So maybe I do want, it's like I do want to show that basically there's some space before this. So one of the ways that they do this is maybe I just make a beginning mark there that says 700. And then from there, I decide how do I get to the largest value here and what am I going to count by? So essentially, I'm literally just saying they technically oftentimes on graphs like this, what they do is you'll see something like this. And so this is their little abbreviation for telling the reader, technically there's a bunch of white space before this. And so I want to be accurate about my number line. I don't want to just say this space is 700 and then the next things I count are all going to be hundreds. I want the number line to still look like a number line where um, uh, every tick mark that I put on there is equally spaced. So instead of putting a line there, I'll put this little, I don't know, electric volt thing, but it's like a dot, dot, dot. So it's like when you make a list and you're writing something in an essay and you put dot, 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 that tells the reader, hey, there's something else here, continue on, with the pattern that you see. This says, hey, there's a bunch of white space here, and that would really suck for you to read, to just scan a bunch of white space to get to the main meat of the data. So I'm gonna show you that there's white space, but I'm gonna skip the white space so that we can just get to the main meat of the data. So you'll see this, see this not only in the book, but you'll see this and like I said, in reality. Some graph you see on Yahoo News or whatever. So it's so I just checked. This looks good. All right, so I'm gonna start at 700 and then we gotta figure out again what's the largest here and then how do I want to count to get there. So the largest that I see is 1200. And then how do we count from there? Now, I will say one of the nice things here is almost all of my incomes here are nice rounded 100 numbers. So I probably want to count by hundreds. If I count from 700 to 1200, that's going to be what, 5? So 8, 9, 10, 11, 12. That's going to be another 5 hash marks, which is going to make, again, visually, it's going to make this decently sparse. So what I'll probably do on this is I probably will make half marks to show 50s because then that helps me show the 850 and then the reader is going to see everything almost exactly the way it needs to be. So what I would do here, this is income. The other thing about this graph, or just the way they draw this, you probably just notice these small differences when you kind of taking an algebra class, now you're taking a stats class. They tend to not put arrows at the end of these, what do you call it? These axes. In algebra, you always put arrows, right? Here they don't. And honestly, that's just because when you're, you know, in a statistics class, when we're giving a graph, we're actually much more thinking about what does this look like to a reader? And I don't know if you ever thought this yourself, but even me, I'm a mathematician. Being in an algebra class, I always thought those arrows were weird, right? Because I mean, they're good. They're trying to show you that the line keeps going. So they're effective communication, but they just look weird and they don't match, in reality, when I see a picture, when I see a graph, there's a natural border to it, right? Um, right now we have Yahoo News, but back when we had newspapers and they put a graph in, see a picture on a piece of paper, it has a natural border to it. The idea that it keeps going on forever is maybe accurate, but it's not true for that piece of art you're seeing in front of you, right? Every piece of art has a border, it doesn't go on forever. So in stats, your graphs rarely, basically almost never have those arrows on it. We're pretending like, we know that that it could keep going, but we are really looking at it as this is a piece of art with a border, and that piece of art is then telling me what's happening with this data. It's not a graph of a function where, so again, what we do in algebra is we have a function, so we know it keeps going, and we want to communicate that to the reader, so we have to put those arrows because that's our abbreviation, that's our syntax to say that it keeps going. In stats, we don't put the arrows. We're not trying to say that. We're trying to give a good picture with borders. Anyways, sorry. That's random and small, but it's a cool difference between the two parts of mathematics. Anyways, so we're gonna count by hundreds up to 1200, and then we're gonna make half marks for the 50s. I think that'll catch this well. So that'll be 800, 900, 1000, 1100, 1200, 800, 900. 1000, 1100, 1200. Is this income in dollars? And I will make half marks to catch my 50s. And if I got half marks here, it makes it look consistent. We might as well do half marks here. So I guess I will do half marks. So there, those are all my 10s between the 20s. Oh, that looks cool. All right, and then again, like I said, the big difference here is there's no rectangles. There's no groups. You're not counting frequency. This is just algebra. I'm just gonna go graph these points. So 800, so income of 800, this person spent 60 bucks. So I'm gonna go to 800 to 60 and I'm gonna make a dot there. And I had another person whose income was 1200 and they spent 200 on recreation per month. So I'm gonna go to 1200, go up to 200, make a point there. And then there's another person, income of 1000. They spent 160 on recreation, so I'm gonna go to 1000, go up to 160. Something like that. That's a little higher, I think, actually. I don't know. Something like that. Then person who spent income of 900 spent 135, so 900. I'm gonna go to 120, 130, and then halfway to 140 from there, something roughly like that. 850 spent 45, so 850, halfway between 40 and 50, so something like this. 907 spent 90, so just the scotch past 900. Notice, so we had two different people who basically had 900 income a month, spent very different amounts on recreation. So 907, this time it was a 90. It's gonna be something roughly like this. And then last person was income of 1,100, spent 150. Something like this. And this would be the scatter plot of that data. Now, one of the first things I want you to kind of like recognize or kind of think about and kind of realize about this plot. So in an algebra class, you would graph functions, right? So you'd have a function. You would, if hopefully they force you to graph by hand, but you would make your x-axis, you make your y-axis, you plot your points. But in an algebra class, those functions, whether it was a linear function like 3x plus 5 or a quadratic like x squared minus 3, those functions, when you graphed them out, did they have a pattern to their graphs? Or did they look like this basically? And hopefully it kind of kicks in. It didn't look like this. Like a 3x plus 5 would look like a straight line. So it was a solid pattern. You kept graphing the points and they kept being on a straight line. Or x squared minus 3 was a parabola. It didn't matter what x value you picked, you plugged it in, you calculated the y value. Every single point that you ended up with looked like it was on the same exact u, right? Or an x cubed looked like it was an s. So the points in algebra, when you graph them out, it's what we call kind of deterministic. They always follow an exact pattern, some shape, but exactly. Straight line, U, and S, whatever, but those points follow that shape exactly. Notice that when I graph statistical data like this, or data from some experiment, some survey, notice that this data does not fit a nice line or a curve or something like that. It does seem to have a pattern to it, but even within that pattern, it's kind of all over the place, right? So like this data looks like it kind of fits sort of a gentle curve like this. Maybe you could even think of it like a straight line. It seems to be sort of sloped up as either a straight line or a curve. But even within, so if you visualize a straight line through this or like a nice gentle curve, maybe really wide upside down part of a parabola, the points are still all over the place, kind of above and below that line that you have in your mind. Statistical data always ends up like this. So when you're doing you have data like this that's two different types of data information that you're getting from one survey or one question or one person or whatever. It always ends up looking basically, so it never has a nice shape to it. So again, that's why we call it a scatter plot. And so what we do in statistics is we look at something like this, and again, you know that it doesn't follow an exact pattern, an exact shape, but we can see that it's pretty close to it, or we can see basically that it looks like it's close to a shape. And so what we will get back to at the end of the semester is we can calculate something called correlation, which is basically how close are these points to that invisible line that you see through it? How close is it to a straight line or to that curved line? So we can calculate the correlation on this data. And the correlation will tell us basically how closely, in this case, income affects the amount of money you spend on recreation. So we will end up doing that by the end of this semester, but this is the graph of the scatter plot, and then they ask you to comment on the nature of the relationship. Basically, they want you to analyze. Again, what we're really trying to figure out here is we're asking the question: does increased income give me increased? Does it tend to make people spend more on recreation? So based on this graph that you see there, what would you guys say? Does increased income tend to bring increased money spent on recreation? So maybe what you're saying here is, what you see here is there definitely seems to be a trend. There definitely seems to be a relationship. It's not, again, it's not exact. So that's the kicker about statistical data versus graphing something in algebra. Algebra is exact. That shape is absolutely, it's a straight line, it's a curve. It is every point is on curve or on line. Here, we're not gonna get that, but it does look like it's pretty close. So overall, looking at this graph from left to right, it seems like as you increase your income, people tend to increase the amount of money they spend on recreation. Now, again, it's not perfect. So notice we basically had two people, I commented on it, we had two people whose income was 900. One person spent 135 on their recreation, one person spent 90. So the reason why it's not perfect is because, again, so a function from algebra, x squared, 3x plus 5, those are nice. They're deterministic. There, you plug in a number, you do the same calculation, you get out a number. People are not deterministic. People are irrational. They're crazy, or people have a lot more influences. So the reason with data like this that we get things that are a little all over the place is just that people are all not like each other, right? Functions all act the same, but people don't all act the same, and they have a lot of different influences on them. So, for instance, these two people who had made 900 bucks for their income, one of them obviously likes, likes like I made the money, I did the work, I'm gonna go out on the weekend and have a good time, right? One of them is like, wait, hold on. I want to have some good time, but I also want to save some money. I got plans for the future, right? I don't need to just go out and spend all my money every weekend. So that's a natural, I mean, you could study, human nature, study human populations, and you'll always see that difference or that kind of, um, about 50% of people tend to be kind of your partiers and 50% of people tend to be your planners, right? So the planners naturally for the same income, they should spend less for recreation, whereas the partiers should spend more. And we kind of do this, see that with this data. This data, again, you can kind of see a straight line. There's almost a curve to it, but all of my data is either sort of above or below that curve. So these are kind of my partiers. They're kind of my planners. Um, so So that's what we start to say with a scatter plot is looking at this, you say there does seem to be a relationship. And so this is where they come up with the word correlation. There seems to be a correlation. It's not completely accurate cause and effect. It's not perfect. But it does seem there as people make more money, they tend to spend more. There's a correlation. They tend to spend more on their recreation. Um, that makes sense in general. So whoever was doing this survey, I mean, it's in some sense their hypothesis was something that we would all expect, right? So as people, as civilizations and countries get wealthier, people are more relaxed, their needs are met. There's sort of that point where you're like, oh, got a bunch of time on my hands and I want to feel good. Let me go to the park. Let me go out clubbing, whatever. So it's like literally once your needs are met and you have more than enough, that is what we tend to do as humans is we spend more, then use more of our budget for recreation, for just having a good time and resting and feeling good. So we could have predicted this. The cool thing about this is now we have an actual graph that shows us that tendency, that correlation. Um, Good. But that's for any of these, if they want you to make a scatter plot, this is what you do. And I was mentioning that I was going to give you guys some vocabulary. So let me see if I can do this without seeing that. Sure I can. Yeah. Oh, that's kind of funny that ended up right there. So some of the terms that we're gonna use that they're gonna introduce here and we're gonna use later when we really look at correlation. So when you get these scatter plots, you might tend to get, some of our scatter plots end up looking something roughly like this. In fact, that's what ours looked like. Where again, it doesn't fit a pattern perfectly, but all my dots tend to look like they're along a straight line that in this case is increasing. So they call this a positive linear relationship. It's linear. It looks like it's kind of dots above and below this invisible line we can see in our mind, and positive because the slope is positive. Essentially, as one thing increases, the other is increasing, like we saw with recreation. As income increases, recreation tends to increase. So the correlation between recreation and income is a positive linear relationship. Now, we don't always get positive linear relationships. So you could have a negative linear relationship. So we could have scatter plots that look like this, where again it's linear, but now as one thing increases, the other decreases. And that's not even, so they call this a negative linear relationship. It is, looks like it's a line, but it's a negative slope. So it's going down, so that's a negative slope. A negative linear relationship is good. It doesn't mean it's actually negative. It's just there are a lot of things in reality where when one thing increases, another decreases, and that's not a bad thing. It's just sort of how the patterns work for whatever you're looking at. So you could have a negative linear relationship. Both a positive linear relationship and a negative linear relationship are good. That's actually what we want to see, because when, again, in section 10.1, when we get there, when you go and crunch the numbers and do the correlation, you're going to end up with a strong correlation. A large correlation. So a large or a strong correlation is good, because then we can say that, again, there's a correlation. One thing tends to affect the other. If I increase this one thing, I'm going to get this pretty deterministic result in the other thing. Again, not perfectly deterministic. Still have your spenders and your savers, but pretty strong, pretty close. However, and I would say not just this is the way reality is, but one of the reasons we study, or one of the things we see easily in statistical data, they're one of the reasons we study statistical data. So now I think I can erase this. It's because, one, not everything has a linear relationship, and not everything has a strong correlation. So again, part of the reason we do these statistical studies in sociology, psychology, economics is you want to assume that one thing affects another, but maybe not. Maybe when you're in the situation, it just looks like it, or you would guess that that's what's happened. But when you actually graph the data out, you see that, oh, there is no relationship. There is no strong relationship. The one thing really doesn't affect the other. And that's important to figure out. There are things that look like they affect each other and they really don't. It's just because you're in a situation where one went up and the other went up. But when you do the experiment and do the survey over a much broader set of circumstances, you realize that it doesn't actually happen. So we're doing scatter plots, we want to keep in mind that it would be great if everything was linear and nonlinear, but for instance, sometimes it's a nonlinear relationship. So notice that this is more like a U. And again, that still tells me something detailed about how increasing this one value or variable, or increasing this one thing that we're measuring, affects the other. So here, as you increase, you get a kind of predictable U relationship. It starts high, it bottoms out, and then goes back high. So they call this a nonlinear relationship just because it's not a line. It could be a U, it could look like an S, look like an X cube. So basically all those functions that you saw in college algebra end up being models or these scatter plots, and maybe some of the relationships, the cause and effect that you have. But sometimes you graph all the dots out and it's just a bunch of dots everywhere. Jackson Pollock painting, just a bunch of stuff everywhere. Don't take that as Jackson Pollock actually is. So if you like contemporary art, you like abstract art, Jackson Pollock is amazing, beautiful, a ton of emotion, because he kind of eschews form, which is nice. But when I'm graphing out statistical data and I see something like this, again, if I'm asking you what's the relationship there, what's the pattern, what correlation do you notice? there is no relationship. I mean, this is a bunch of randomness. And again, that's something we need to know. That is still a positive result. So it's telling you that, so again, when we get to the section 10.1, we're gonna crunch the numbers and it's gonna show you a very low, if not zero correlation. So there is no correlation. There is no really cause and effect. And that's something that I need to know about circumstances. I need to know just as much if there is no relationship as, oh, there is a relationship and this is what it is. It's positive linear or negative linear or non-linear. Good. So these are sort of in general, I would say these are the scenarios you often get with scatter plots of data like this. All right, good stuff. That's it. That is this section. Your homework is literally, they're just gonna ask you to do some scatter plots and give some very basic brief analysis of what you see there. So that is good. I will see you guys next week. We'll start chapter 3.